Unit 12.4, Traversing Arrays. Okay, before we jump right into 12.4, just want to make one little correction. Not a big deal, but something we need to recognize. I had the word button here instead of buttons in the last unit. It's not a big deal, but when you're writing code, you want to see the plural when you see a variable, then that will suggest that it is an array. Okay, not just one button, but many of them. All right, let's go and traverse. Let's traverse. So we already see how to traverse an array. Literally, when we print, we are traversing. So when we go around and start from 0 up to length minus 1, it's less than, so that's why it's length minus 1 plus plus. We're going from the 0 all to the last one, processing each one in the array. That is called traversing. We could go forward, we could go backward, same idea. I went ahead and I did some. So I'm just going to show you what I did, and hopefully you could follow and see how we can traverse an array to do different things. So for the first one, I have an array of scores. It's filled up with some scores. Let's consider these test scores. And I've written some methods below, and we're going to walk through the methods. But before we do that, let's see what we are doing here. We are going to print the even numbers in the scores. So I see print even scores. When you read your code, it should actually make sense when you read it. Print even scores. So we're printing the even ones from here. Now, unit 12 dot means this is static. It's a static call. Then I'm printing some new lines so that we could separate them. And then I'm printing the sum of the scores. And then after that, I print the average. I'm doing all prints here, so I'm not returning a value. These are going to be void. And here I have a bunch of names, another array. And what I'm going to do is print all the names that start with C. And I'm going to also print the names that are greater than 3 in length. So for example, Gary would print because it's 4. And finally, I'm going to mix and match here, something from old, something from new. I want to create an array that holds 20 random integers on some interval AB. In this example, I'm going from 30 to 60. Obviously, this is a non-static call because you don't see it italicized, and you also don't see unit 12. You see object, so I have to create an instance of the class. Since we're in unit 12, it's going to be unit 12 class, create an object, and then call the value, store it as random integers, and then I print the array. This is not a method that's listed here in terms of what to do, but I'm printing the array because we were printing arrays over and over again, and I would have to borrow a for loop to print it here. So instead of doing that, I created a method to do it. Here comes the methods. First, print even. So it takes in an array. Well, all of these methods are going to take in some kind of array except the last one, or last two I should say. So here it says take in the array and do an indexed loop. Okay, I want to make sure we get an idea of two types of loops. We could use an index loop and we could use a for each loop. The index loop is the one that we've been using all along. Start at 0, go up to length minus 1, and do whatever you want. Now, here I'm doing check the value at I, see if it's even, and if it is, print it. Okay, print even, pretty straightforward. Processing every single one using the index. Print sum, same idea, index looped again. See that? I created a variable to hold the sum, and I keep adding them on, and when I'm finished, when this loop is completely finished, it would have added every single one, and I print the sum. Index loop for each loop. Now I'm doing the average, pretty similar to the sum, except I'm using a for each loop. Look how the for each loop looks. For each integer value in the array A, add up the sum. See, I could have done this the same way I did this here. Just want to show two different flavors, and when I'm done, I'm going to print the average by dividing the sum by the length. Realize my sum is a double, even though I'm holding all integers. Why? Widening conversion. Old meets new, kind of like bringing it all together here. So since this is all 4 bytes, I could go to 8. It's just going to make sure that each one is going to be some number 0.0. So when I'm done, when I go and divide, I don't get truncation, because if I made this an int and I divide an int with an int, you won't get me the decimal portion. All right, names that begins with C for each loop. For each string now name in A, because A is an array of strings, if it starts with C, print it. And I'm printing it vertically. I'm printing this vertically. I'm printing this vertically. And I'm printing this horizontally. See, we're going all the way back. All the way back. So now we're going to do print names that are with more than 3 letters. Look at that. For each loop. for each string name in the array, if its length is greater than 3. Now look at the length here versus the length for the array. Okay, one is blue, no parentheses, because that's a variable, but this is a method. So the name, if it has a length greater than 3, print it, printing them vertically. Finally, we're generating values. So what I'm doing here, I'm taking in the interval from A to B, and then I'm supposed to write a precondition and stuff like that here, but I wrote it up above. A has to be less than B. So I made a random number generator, old meets new, random generator. I create an array that's going to hold 20. At this point, it has all zeros. Then I use an index loop to make sure I fill up every single spot with a random number. Look at this. Remember this one? Remember the first number is easy. You just put it here. How does the one in here look? Well, take this guy and add a 1 on. Right? So let's see if that works. And we're going to try and see if it doesn't work, then we got to make some adjustments to it. Okay? And then finally, we're going to print the array to see if all this stuff is working. Now, I should actually use an easier range than 30 to 60 up there. So I'm going to go ahead now. Before I do that, let me just jump in and say something about the for each and the index loop before I run this. For each loop and index loop, there's two ways you can write loops, and there's specifically for data structures like arrays. This is used for when you're processing every single one. It's not to be used if you're going to change the array. If you're going to change up the array, this is not going to work, okay? Any changes to the array, this is not good. Changes to the data structure for each loops, don't use them. Use the index loop. If you're just going to go through every single one, though, and process traversing every single one, for each loop is perfect. It just does that. It doesn't go out of bounds, unlike this, right? When you run an index loop, you could go out of bounds because you're looking for the index, and you may be out, either negatively or too far on the right side. This cannot go out of bounds because we don't have an index. That brings me to another thing. If you're using, if you're trying to write a method, I should say, or writing any code, and you want to specifically know where you are in the array, you need the index loop, because this you don't know. We just say for every single one, and we can't say at what point we were at the second one, the fifth one, the 10th one. We don't know. So these are some little pluses and minuses as index and for each loops are concerned. But let me just run this, and I'm interested in the last one to see if this one works, because I'm trying to come up with a general formula, okay, for random number generation, right? I'm trying to figure out if I could come up with a general formula. So let's see if that works. Let's run it. All right, so here we have it. These are some things that we printed before, and I think this will be my sum. Let's see what all we have here. All right, we print the evens, and we're printing the even scores, and we're printing the average here. So let's see. This one is my average. I think that's my average. This is my sum here. Did I print my evens? Let's see if I did. Let's make sure I did. I did. So where are my evens? Oh, here they are. Okay. So I think I might have to put a print so that this drops down so it's not and so let's go ahead and do that again. I'm going to put a print right before the evens as well, because I want to see all my pieces. The stuff from before is bothering it, so I want to make sure everything is looking nice. So here we go. All right, so here are my even numbers. All right, that looks right. And here is my sum. Okay. Next one is my average. I could tell that was the average because it has some decimal portion. And I print the names that begin with C. If that works, yeah, I print them vertically. Carol, Carmen, Carly, and Corey are fine. And what about the names that are bigger than 3, more than 3 letters? Yep, that's good. These are all more than 3. And then finally, I print the array. Well, let's see if it worked. Well, I was interested in this one. We want to go from 30 to 60. So anything, and inclusive. So anything bigger than 60 should be an error. Oh, look at that. Well, this is 69 and 83. So we're incorrect. Incorrect. So how can I come up with a formula then? So let's see. If I wanted a 30 to 60, let's think about that. it should be gen.nextInt. I'm going to think about this. And so that's a tough part. Let's go with the easy part. So we got that part right. We got the A out here. So how does this look? Well, since I'm going up to 60, I want 31. Let's see if that's right. 31 goes from 0 to 30. So when it generates a 0, I add 30 on, I'm at 30. That's good. And when it generates the last one, the very last one, the highest, 30, I can add on 30. So this is supposed to be 31. Let's check this what we have. Let me close this, scroll down. I want a general formula. This is important. So 1 is in it, but it's not quite B, right? Because that would have been, let's go back up. That would have been 61. That's not correct. So we want 31. So how are we going to do this? Well, it looks like we have to take the B and subtract the A, right? So let me just go ahead and try that and see if that helps me out. So B minus A plus 1. Let's see if that works. Run it again. This time I'm not interested in all the others. I know those work. Let's just see. Well, it's looking good. This is looking good. Let's just go ahead and look and see. So we are trying to print every value that we generated, and the values need to be 30 to 60. Just come back, scroll up and see if I could find that. So here, 30 to 60. So let's see. Is there anything below 30 or above 60? Don't see any value. So I think we found it. I think we are correct. Let's see if this is true though. Is this the same as 60 minus 30 plus 1? Yes, it is. So there we have it. A nice general formula to generate random number on a closed interval. All right. So what I wanted to show here is traversing. So we traversed in index loop and we traversed with the for each loop. We already know that the index loop is good if you want to know if very specific spots and so on, and you got to be careful, it could go out of bounds. This is to process every single one, the for each loop, but it's not going to go out of bounds. So you have to make up your mind if you want to use a for each loop. Some people just use index loops all the time, and nothing's wrong with that. I just want to make sure I show you both so that in case you want to just simply walk through an array and check something out, that's pretty straightforward and basic. You could use this, it avoids all this typing. All right, let's recap. Traversing arrays. It's literally using a loop. We could do it with an index loop or for each loop. We want to write methods to do this, okay, because we want to make them as generic as possible. That's why we did that. Now, to review, remember, some methods are non-static. See, like this, you need an object to call it. Some are static, okay? We could pass arrays in, just like variables. We can also return arrays, just like variables. See, how we generate and we return an int. We could turn strings, we could turn any type, okay? Make sure we get that clear. So traversing arrays, we need our loops. I would say we want to use the index loop more often than the for each loop, but there are times when the for each loop comes in handy. 12.4, traversing arrays, that brings us to the end of 12.4.